Hey guys, Mr. Backward here. This is our review video for test number 6. Taking a look at problem number 1, we've got 5 raised to the x power equals 125. So what we can do with this one is, since it's in exponential form, we're going to switch it over into a logarithm. So this base of 5 becomes the base of our logarithm. So this is log base 5. The 125 is what we're going to evaluate, and then this is going to equal the power of x. So we get log base 5 of 125 equals x. Now if we evaluate log base 5 of 125 in our calculator, we should get 3 as the x value for that one. If we take a look at number 2, this one's also an exponential, but this one has a base of e. So when we look at rewriting this one in logarithmic form, we're going to use a natural log. So we're going to go natural log of 5.7 equals that x value. And when we type this into our calculator, we're going to round to 3 decimal places. I get 1.740. On number 3, if we go logarithmic form on this one, we're going to get log base 7 of 410 equals x plus 2. Now in order to get x all by itself, we're going to subtract this 2 over to the left-hand side. But we have to be careful. I'm going to write it as negative 2 plus log base 7 of 410 equals x, and then we can type this entire left-hand side into our calculator, negative 2 plus that logarithm. And again, we're going to go to 3 decimal places. We should get x equals 1.092 for that one. Taking a look at number 4, we've got e to the 2x minus 3 e to the x plus 2 equals 0. We're going to treat this one like a quadratic and do some factoring with it. So I'm looking at that plus 2 and that minus 3. In order to multiply to 2 and add up to negative 3, it's going to be minus 2 and minus 1. But we're not just dealing with regular x's, we're dealing with e to the x's. So this is e to the x minus 2 and e to the x minus 1 equals 0. Now if we think factoring, once we factor, we're going to take each factor and set it equal to 0. So we get e to the x minus 2 equals 0, and e to the x minus 1 equals 0, and then we're going to work on solving each piece. So with this first one, I would add the 2 over, so we get e to the x equals 2, and then since this has a base of e for the exponential, we're going to do the natural log of 2 equals x, and then if we type that into our calculator and go to 3 decimal places, we should get 0.693. Taking a look at the second one, if we add that 1 over, we get e to the x equals 1, and then rewrite it using a natural log, so the natural log of 1 equals x. And on this one, if we evaluate it, we get 0 as our answer. On number 5, we need to work on getting this exponential e thing all by itself. So the first thing I'm going to do is add that 7 over to the right-hand side. So we get e to the 4x minus 5 equals 11,250. And then this exponential has a base of e, so we're going to change it to a natural log of 11,250 equals 4x minus 5. I'm going to add this 5 over. So those things cancel out, and we get 5 plus the natural log of 11,250 equals 4x. Last step is going to be to divide everything by that 4. And then if we type this into our calculator and go 3 decimal places, I got 3.582 as the final answer for that one. On number 6, we've got a base of 10 for the exponential, so we're going to use a base 10 logarithm to evaluate this. So log base 10 of 3.91 equals x. And if we type this one into our calculator, we should get x equals 0.592 for that one. On number 7, we start dealing with some logarithms. So we've got log base 3 of x equals 4. To solve this one, we're going to switch it over to an exponential. So the 3 becomes the base of the exponential, the 4 goes up as the power, and this equals x. And if we take 3 and raise it to the 4th power, we end up getting 81 as the answer for that one. On number 8, we need to get this natural log all by itself. So the first thing I'm going to do is divide that 6 over to the right-hand side. So we get the natural log of 2x equals 5. And then again, I'm going to rewrite this one as an exponential. Since this is a natural log, it's got a base of e. So this is e to the 5th equals 2x. And then to get x all by itself, we're going to divide both sides by 2. And if we go 3 decimals, we get x equals 74.207. On number 9, we've got two logarithms happening on the left-hand side. So before we can start solving, we need to condense those things down. Since this is addition, when we condense addition, it turns into multiplication. So this is going to be x plus 5 times x equals 2. And then with this logarithm, we're going to rewrite this in exponential form. So 6 squared equals, I'm going to distribute this x, so x times x is x squared, and x times 5 is 5x. Now 6 squared is just 36, so I'm going to subtract 36 over to the right-hand side. Since this is a quadratic, we'll want to have 0 on the left-hand side in order to solve this. So we get 0 equals x squared plus 5x minus 36. And then we're going to do some factoring. So this is going to factor into x plus 9 and x minus 4. And then if we work on solving each one of those, we're going to get x equals negative 9 and x equals 4. Now one thing we have to remember is we can't evaluate logarithms of negative numbers, so this x equals negative 9 can't safely be plugged back in, so the only answer for that one is going to be x equals 4. Taking a look at number 10, we're also going to have to do some condensing on this one. Since we've got subtraction happening with these logarithms, we're going to turn that into a division problem. So we've got log base 4 of this x plus 2 is going to go on top, and x minus 1 is going to go on bottom, and this equals 1. Now we're going to rewrite this in exponential form. So this base of 4 becomes the base on our exponential, this 1 becomes the power, and it equals this fraction x plus 2 over x minus 1. 4 to the first power is just 4, so I'm going to get rid of that first power because we don't really need it there. In order to work on solving this one, I'm going to multiply that x minus 1 over to the left-hand side, so we're not dealing with a fraction anymore. So if we take 4 times x minus 1, we're going to get 4x minus 4 equals x plus 2. And then we're just going to do some algebra solving. So I'm going to add this 4 over to the right-hand side. So we get 4x equals x plus 6. And then we're going to subtract this x over. So we get 3x equals 6. And then dividing both sides by the 3, we should get x equals 2. On 11, the right-hand side has two logarithms, so we're going to work on condensing that down. Left-hand side isn't going to change at all, log of 5x plus 1. Right-hand side, since this is addition, we're going to turn into multiplication. So this is log of, I'm going to distribute that 2 right away. So 2 times 2x is 4x, and 2 times 3 is plus 6. Now we've got logarithms on each side, so we can use the one-to-one property to cross those things off. And then we've just got 5x plus 1 equals 4x plus 6. And then if we do some solving, subtract the 4x over to the left-hand side, we get x plus 1 equals 6. Subtract the 1 over, and we get x equals 5 for that one. Taking a look at number 12, we've got a natural log of that square root of x plus 3 equals 1. First thing I'm going to do is rewrite this in exponential form. Remember, natural logs are base e's, so this is going to be e to the first power equals the square root of x plus 3. Again, just like we had earlier, a first power we don't really need to write in there, so I'm just going to turn that into a plain e. And then in order to get rid of this square root, I'm going to square both sides. So the square root and that squared cancel out. On the left-hand side, now we have e squared equals x plus 3. In order to get x all by itself, we're going to subtract that 3 over to the left-hand side, so we get e squared minus 3 equals x. And then if we type this into our calculator, going 3 decimals, I've got 4.389 as the answer for that one. Taking a look at number 13, we want to figure out how much money we need to invest to get $2,000 after 3 years. Our savings account is going to have an interest rate of 0.25%, and we're going to do 3 different things. We're going to have compounded monthly, compounded annually, and then compounded continuously. So if we start with part A, compounding this monthly, we want to have the $2,000. So that's going to be our A value on the left-hand side. So 2,000 equals P times 1 plus our rate. We have to remember to turn into a decimal. Right now it's a percent, so we need to slide the decimal 2 places to the left. So we get 0.0025 over, since we're going monthly, our N value is 12. and then this is going to be raised to the power of 12 times 3, since this is going to be for 3 years. Now what I'm going to do is I'm going to work inside of the parentheses first. So we've got 2,000 equals P times, if I type this stuff into my calculator, and I'm actually going to carry a bunch of decimals just so we can be as exact as possible, we get 1.000208333. And then with this power, 12 times 3 is going to be 36. So now if we take this number raised to the 36th power, we get 2,000 equals P times 1.007527408. Now in order to get P all by itself, we're going to divide both sides by this big long decimal. And since we're dealing with money, I'm going to round to 2 decimal places. We should get P equals $1,985.06. So that would be our starting amount that we need to get $2,000 after 3 years. For part B, our setup is going to be very, very similar, except we need to change that N value. Now we're compounding this annually, so that means just one time per year. So if we change that and type this stuff inside of the parentheses into our calculator, we get 2,000 equals P times 1.0025 raised to the third power. And if we actually do that third power, we end up with 2,000 equals P times 1.007518766. And then just like we did on the last one, in order to get P all by itself, we're going to divide by that big long decimal. And when we do that, we should get P equals $1,985.07. So very, very close to what we got on the last one, but just a little bit different. For part C, we're going to have to change our setup completely because now we're compounding this continuously, so we have to use our other interest formula. So we want $2,000 again. This is going to equal P times E raised to the 0.0025 times 3 power. So 0.0025 times 3 is 0.0075. And if we actually do e to the 0.0075 power, we get 2,000 equals P times 1.007528195. And then, just like we've been doing this whole time, in order to get P all by itself, divide by that big long decimal. And this answer is going to be very similar to that first answer that we got. We get $1,985.06 for this one. In number 14, we're talking about the growth of a strain of E. coli, and we're given this function n of t equals p times e to the kt power. P is going to represent our initial number of bacteria, t is time, being measured in minutes. So I guess what we're told in the first part is that the doubling time is 20 minutes, and we're starting with 1,000 bacteria. So in part A, we want to find the growth constant k, and we're going to round that to 4 decimals. So if we think about what we've got, the time is 20 minutes, and our initial population doubled. So if we started with 1,000 bacteria, then this n value on the left-hand side, well, if we double 1,000, we get 2,000. So 2,000 equals 1,000 e to the k times 20, because it was 20 minutes. Now, if we work on solving this, we're going to divide both sides by the 1,000. So we get 2 equals e to the k times 20 power. Since this is a base of e, we're going to switch this to a natural log. So natural log of 2 equals k times 20. And then we're going to divide both sides by that 20. And if we go 4 decimals on our k value, we should get 0.0347. Now what we want to do in part B is we want to figure out how long it's going to take us to get 9,000 bacteria. So for part B, that n value on the left-hand side is now 9,000 equals 1,000 e. We're going to use this new k value that we just found, 0.0347 times our t, since we're trying to find the time. Now we're going to divide both sides by 1,000. So we get 9 equals e to the 0.0347t. Switch this over to a natural log. Natural log of 9 equals 0.0347t, and then divide both sides by that 0.0347. We end up with a t-value of about 63 minutes. Last example, we're talking about the population of Sasquatch in Bigfoot County. We're given this population model to help us out. We're starting in the year 2010. So in part A, we want to find out how many initial Sasquatch there are. So we're going to use a t-value of 0. So all we have to do in this one is plug in 0 for our t. So we're going to evaluate p of 0. So we get 120 divided by 1 plus 3.167 times e to the power of negative 0.05 times plug in 0 for that t. Now, we should be able to just type this into our calculator. We're going to round this to the nearest whole Sasquatch. So once we do that, we should get about 29 Sasquatch. In part B, we want to find the population in 2013. Well, if 2010 was 0 for a t-value, then 2013 would be a t-value of 3. So we're going to look at p of 3. So again, we're just going to take everything that we have and plug in 3 for that t-value. So we get 120 over 1 plus 3.167 e to the negative 0.05, and this time we're plugging in 3 for our t-value. When we type all of that into our calculator and round to the nearest Sasquatch, we should get about 32 Sasquatch. In part C, we want to figure out when the population is going to reach 60. So now on the left-hand side, we're going to turn that p-value into 60. So we get 60 equals 120 divided by 1 plus 3.167 e to the negative 0.05 t, because we're trying to find the time. Now what I'm going to do is a little bit of cross-multiplying. I'm going to put this 60 over 1 and then cross-multiply these things. So 120 times 1 is just 120. And then I'm going to do 60 times this entire 1 plus 3.167 e to the negative 0.05 t. I'm not actually going to distribute the 60 in there, but what I'm going to do is divide by the 60. So on the left-hand side, now we've got 2 equals 1 plus 3.167 e to the negative 0.05 t. I'm going to subtract this 1 over to the left-hand side. So we get 1 equals 3.167 e to the negative 0.05 t. Now divide both sides by that 3.167. And I'm going to go 4 decimals on the left-hand side here. I've got 0.3158 equals e to the negative 0.05 t. Now this is a base of e with the exponential, so we're going to switch this to a natural log. So natural log of 0.3158 equals negative 0.05 t. And then we're going to divide both sides by that negative 0.05. And when we do that, we should get a time of about 23 years. So if 2010 was 0, 23 years later, that would be the year 2033. That's going to be it for this video. Thanks for watching.